All right, as we get started today, let's go ahead and take a look at those problems that I put on the chalkboard for you to complete for homework last night. Practicing with order of operations, obviously the first thing we'd have to do in this particular first problem, Maddie, is to simplify the... You could distribute the 3. That's one way to get rid of parentheses, I suppose, but generally speaking, since 6 and 1, like if this were an x and a y, yes, you distribute the 3 to get 3x plus 3y, but since it's a 6 and a 1, I would just add them. Yeah, so normally we would just combine and add to get 7, though it's not necessarily wrong to distribute there. So parentheses and other grouping symbols, in fact, let me drag this over here just a little bit, because why not? Parentheses and other grouping symbols, always the first thing we'll take care of, and of course that's what we have here. Once we've got that, then we take care of any exponents, but obviously none here. From there we'll multiply and divide. So Maddie, now what? To get, and at the same time, now if you'd already distributed, then that step was already finished. So you wouldn't have done anything there, but as is, we'll add to get, or multiply to get to 21. And then it's just add, subtract in the order they appear. We don't necessarily add before we subtract, but here we will, because addition comes before subtraction. What do we get for our answer? Good, I end up getting 16 for the answer. How many had that for this first problem? Looking at the next one, Noah, what first? Good, because it's in parentheses, the 12 divided by 3, which gives us 4. All right, and then what? Right, we've got these two terms. One's got a division, one's got a multiplication. Now, technically, we would do the division before the multiplication, but because they're separated, it really doesn't matter. When we multiply, we get, and when we divide, we get 3, and 3 plus 36 gives us 39. We get that answer for the second one. Ooh, only Noah did. Okay, questions? All right, looking at the next one, Brecken, what first? Good, to get 2, then what? Good, to get, and at the same time, to get help 24. All right, and that'll add together to give us 29. I'm going to get 29 for this answer. 29 here. All right, and looking at the last one, back to Maddie. All right, there's our answer to the last one. How many had 24 the last one? Okay, questions. Brecken, seems like we had a little bit of trouble here. These are very similar to problems. These are, it looks like I was copying off the exam. These are not actually the exam problems, but they're very similar. Questions? All right, do you feel like you understand it better now, having tried it? And okay. All right, let's come to the this evaluation or numerical substitution that I gave you. I told you x was 3, y was -2, z was 4. We're still using order of operations, okay? So that hasn't changed. It's just that we have to plug the numbers in. And that really, truly is the first step anyway. Just plug in the numbers. So instead of 3x minus yz, no, I could rewrite this as... Right, and I will recommend, as I showed here, when you plug numbers in, I would recommend putting them in parentheses so that you can see exactly what you're doing. Now here, of course, we have a multiplication and a multiplication. Well, order of operations says you multiply if there's no parentheses or grouping symbols or exponents to worry about, so Noah. Well, I get a 9, I have a minus, and I multiply to get -8. But do we ever really subtract in algebra? No, so I'm going to change it to adding a positive. The other alternative is to look at this as a negative, maybe even a -1 class, and say -1 times -2 times +4 is +8, and just go straight to 9 +8. That would work as well. Our answer should be 17. How many have that answer here? All right, looking at the next one, Maddie, how should I plug things in? And we need to take care of exponents before we multiply and divide. What do I get when I cube the, well, yeah, a lot of students will make this mistake. So, well, 2 times 3 is 6, and then cubed is 216. Careful, it's cubing the 3 first to get, and that's what's going to get multiplied by the 2 here in just a moment. Same thing here. I'm not going to multiply negative times negative gives positive, but rather I'm going to square the negative 2 to get positive 4, and then that will be subtracted. And of course, we have this plus 4 here. From here, Maddie, let me move this over, make sure you can see. And of course, since the negative 4 and positive 4 cancel, our answer is just 54. How many had that for the second one? How many ended up with a 216 at the beginning? Okay, good. I'm glad none of you did that, at least. Anyone say negative, negative, positive, and get a plus 4 right here, so you ended up with 62 for your answer? Okay, careful there. Again, the negative 2 gets squared to a positive 4, but this negative or subtraction is still there. Looking at the next one, I mean, x, y, z couldn't be easier. Literally just 3 times negative 2 times 4. Noah? Negative 24. There you go, because there is a single negative. That's an odd number of negatives. So negative 24, we all good on that one? All right, then the last one, we've got the x to z over y. Of course, that's 3 times 4 over negative 2, which gives us what, Brecken? Good, negative 6 could go on the last one. Questions on any of this? All right, let's continue working on different things that you'll see on the exam. Again, the idea of the exam, Maddie, in your case, and Gavin, in your case, since you're going to be exempt from it, you're not so much thinking exam, obviously, you're thinking Algebra 2, and really that's where the exam is geared anyway. So for Noah and Brecken, everything on the exam is really the, okay, here's everything I taught in Algebra 1. Obviously, I'd like you to remember everything, but for you to be successful in Algebra 2, what do you need to remember when the year starts? What are the most important things that I taught you? And so that's really the emphasis. So hence all of this review benefits you, Gavin, and you, Maddie, even though you're not taking the exam. So again, be thinking in terms of next year, being ready for Algebra 2, making next year easy as possible. One of the things we've worked on a lot lately with radicals, but I wanted to make sure we reviewed it with just general binomials as well, is the ability to multiply two similar binomials. And how do we multiply similar binomials? Class? Thank you, Maddie. FOIL. I couldn't hear it, but I could see her mouth go, ooh. So I was like, I think she just said FOIL. Yeah, well, FOIL similar binomials. What if I had something like a 3m minus bn and a 3m plus bn? Maybe we might get a bn squared just for fun. What about something like this? What would we need to do, class? It's a sum and difference, so we're going to square the first, square the last, put a minus sign between them. What if I had something like a 5b squared cd cubed times 2b to the 7th c to the 5th minus 11 b to the 4th f plus 2. What would I need to do here, class? Distribute. It's a monomial times a polynomial. Let me go ahead and slide the camera over to make sure I get the whole board here. And if I had something like a 3x cubed minus 8y squared squared, what would I need to do to square the binomial? Good. Square the first, square the last, multiply, double to get that perfect square trinomial. At your seats, working all 3 of these. At your seats, working all 3 of these. Let's take a look at these together. On the first problem here, we're just foiling. So you multiply your first, side number letter, positive 18b to the fourth. The outer inner, again, ideally we do in our heads. With radicals, I tend not to. You certainly don't have to. You could write the positive 21b squared z, negative 30b squared z. But remember, we're dealing with numbers anyway. I tend to just focus on this is a 21, that's a negative 30. And I usually think money, if I've got $21 and I have to try to pay 30, that's going to put me $9 in the hole. And then I keep the letters. I keep the b squared, I keep the z. And then for the last sign number letter, again, negative 35z squared. We get to go on the FOIL problem. Everyone get to go on the FOIL problem. And we'll want another FOIL problem here in just a second. Look at the next one. Square the first, 9m squared. Square the last, b squared into the fourth, put a minus sign between them. Oh, again, don't let the fact that we've been working with radicals lately throw you off on something like this, okay? Don't let the easy stuff become hard because we've been working on hard stuff lately. Good to go on the second one? Looking at the third one, distribution. Just sign number letter 3 times in a row. Sign number letter here, sign number letter here, sign number letter here. Remember, add the exponents, okay, of the same letters. Good to go on your answer there. Good to go. All right, and then the last one, squaring the binomial. Square the first. Remember, when you raise the power to a power, multiply the exponents. You get a 9x to the 6th. Square the last. That, of course, will give you your positive 64y to the 4th. And then multiply and double. So 3 times 8 is 24. Times 2 is 48. Keep the negative sign. Keep the x cubed. Keep the y squared. We get to go on the last problem. All right, Brecken, you're sure you don't need extra practice with the first couple?
I got the first one right.
Okay, it was just the second. All right, what was your answer?
It was 9m squared negative b into the fourth.
I got you. So you just lost the b in the shuffle there, so a quick reminder there.
I thought they were together.
Oh, okay. Well, that would be written this way: bn squared. And then, of course, if you had a bn squared here, right, in the sum and difference, then it would give you a bn to the fourth. So, yeah, if they're not actually physically grouped with parentheses, assume them separate, b to the first n squared. All right, another thing, of course, is the exact opposite of this. Factoring. Now, in theory, we should be really good with factoring because we've been doing it, it seems, all year long. Really, it's only been since late November, I guess, shortly around Thanksgiving time. But we've been doing an awful lot of factoring. Of course, the first thing we always check for when we factor, class. What's the first thing we should check for when we factor? Common factor. Yeah, common factor. Have I told this you all before? You're not allowed to forget anything? You're going to have a really hard time in Algebra 2 if you don't remember the stuff I taught you in Algebra 1. A really hard time in geometry if you don't remember the stuff you learned in Algebra 1 and 2. You have a really hard time in pre-calculus if you don't remember all the stuff from algebra and geometry. You have a really hard time getting into college, taking that college board test if you don't remember the stuff you learned in 8th grade, and 9th grade, and 10th grade, and 11th grade, and 12th grade. Don't put things in your short-term memory. Remember things. You remember things you care about, so maybe up the care level. It's a little late now for this, I suppose, but yeah, common factor. How many times did I ask that over and over again? Really no excuse for forgetting it, to be frank. If we got a 5, a cubed b, negative 10b squared cd, plus 45 a b to the 5th x. At your seats, factor. And I'll put up some more in a moment. Let's start just by looking at the first one, since my faith in your memory has been shattered. Brecken, what's the common factor here?
5AB.
Well, you're right about the 5, because I see a 5 everywhere. I also see a B everywhere. I don't see an A everywhere. Just 5B. What would we get when we factor out a 5B, Brecken? There we go, good. Everyone else good to go as well? Remember factoring out the common factor. Now, there's other things we talked about as well. I wanted to make sure we hit that first. We said if we happen to have a perfect square trinomial, class it'll factor into a binomial squared. If we happen to have a quadratic trinomial, we'll factor that into a couple similar binomials using backwards FOIL. This is going to be a rough exam. If we happen to have a difference of squares, that'll factor into a sum of difference. Can we remember that one? If we happen to have a 4-term polynomial, we would factor that using a technique called grouping. You remember that one? We barely did that one. Keep factor these problems. I'm going to put another one up here in just a moment. I'm glad that you remember it. Anyway. Some people's kids. All right. All right, for sake of time, look up this way. We had a difference of squares. Hopefully you identified that. No common factors, but a difference of squares factors into a sum and difference. Did we get this answer for the difference of squares? I'm going to unexempt you. Questions on this, Maddie? All right, looking at the next one. Common factor first. There's a 3 everywhere. Get that out. And then, oh, wait a second. Perfect square, positive, even. That's a PSG. I can factor that into a binomial squared. Or you could look at it as quadratic. And you could have backwards folded x and x, negative, 2y squared, 2y squared. And that would have worked as well. I'm going to get one of those answers for the PST. And then for this next one, I'm not sure if you had time to finish or not, but we pull out the 5x. Lo and behold, a quadratic trinomial, not a PST, that's not a square. Keep the 5x, don't lose the common factor, right? X and x, signs are going to be different. 7 and 3 can give you a 4, specifically a negative 4 if you have a negative 7, and a positive 3. Questions on factoring. We transitioned out of factoring as we came back from Christmas break and talked about fractions, and really the key to surviving fractions was to be able to factor. And to remember that the first thing we always check for when we factor is a common factor. Okay, there we go. All right, we just needed a little refresher. That's what it was. It just been so long. Okay. But anyway, so with fractions, we said if you want to add fractions, of course, you have to have a common denominator, right? Preferably the least common denominator. So if I had like a 3x minus 7 over 5 and a negative 9 minus 6x over 10, positive 5x over 2, we said we need a common denominator, the least common denominator for these fractions. And I said for an addition-subtraction problem, your key to success was to start with a big long line. Go and do this with me. What's the LCD, Brecken? So that's what goes below the big long line. And the key is to make all of these numbers become 10s. But that ain't a 10, so what do I do to it, class? And what you do to the bottom? So we're going to change our numerator as we copy it down, class. Thank you, Brecken. For the next one, hey, that's already a 10. I don't got to change nothing except it's a subtraction. And do we ever really subtract, class? No, we add the inverse. So what do I copy above the line? Someone besides Brecken. Good. Both signs have to change. And then, Maddie, what do I do with the last fraction? To copy down a... And we just combine our like terms. Combine all the x's together to get what, class? 37x. We combine our nothings to get our constants, would be a better way to put it. More mathy sounding. Negative 23. All over 10. I've got remedial math for him. We said if we want to multiply fractions, like for instance a 10m cubed over m squared negative 9 times say an m negative 3 over 2m, technically you can just multiply straight across, right? We could distribute here, we could distribute there, and then try to reduce, but so inefficient. So we want to cancel before we multiply, but you can only cancel factors. You can only cancel factors. You can never, stop my nervous breakdown just before it happened. You can only cancel factors. You can never cancel terms. Well, these are factors. These are factors. I can cancel this m with one of these m's to get, class, m squared. And I can cancel the 10 and the 2 to get 5 and 1. But I can't cancel anything here because these are terms. And these are separate terms. Well, I can do what to the m squared minus 9, class? You want factors? Go ahead and factor. Yeah, what do I get? Yeah, m plus 3m minus 3. Now, here I can't factor it. And remember, if it's a polynomial, meaning you have separate terms, and it doesn't factor, just group it. Put it in parentheses. And now, what else can I cancel, class? The m negative 3's. And so for our answer, we're left within the top 5m squared, and in the denominator just. But remember, whenever you cancel something out of the fraction, we need to account for it. And there was an m as a factor that canceled, so we need to set it unequal to 0. Also, this m negative 3 canceled. We need to say that m can also not equal positive 3. And we include those excluded values with our answer. At your seats, do this one. 5m cubed positive 20m squared over m squared positive 3m negative 4 times an m squared positive 1 over 10m. If I check your work on this one, should have factored out a 5m squared, leaves you with m plus 4. Should have factored into m plus 4, m minus 1. Should not have factored the sum of squares. It doesn't factor. Group it. Can do some canceling. Cancel an m away, cancel an m plus 4 away, cancel a 5 away. Make sure we specify m can't be negative 4 or 0. Of course, you don't have to say 5 can't be 0. And there's our answer that we're left with. Questions on this? How many on the right track even if we didn't finish? How many tried to factor the sum of squares? Don't factor a sum of squares, young people. Just don't do it. Just say no, like you learned in health class recently. All right, looking at this here. Division. It's not quite the same as multiplication, but it's close. Division is multiplying by the reciprocal. So anytime we see division, we know really we're going to change that to multiplying by the reciprocal, right? And then we can do exactly what we just did. We'll factor. Here we can factor into, feel free to speak up. Signs are going to be the same. They're both going to be negative. 4 and 1. There we go. Here factor out a 3x to be left with x negative 4. That's a monomial. Those are already factors. Here, this is a difference of squares. Now that does factor. And then, of course, we can cancel the x negative 1s. We can cancel the x negative 4s. We can cancel the x and the x squared to get x. We can cancel the 3 and the 6 to get 2 and 1. It looks like we're left with a 2x in the top and an x plus 1 in the denominator. X cannot be, class. 4, 1, or 0. Questions on fractions? Inequalities are like equations. 7x plus 3 is less than or equal to 24. We solve them like equations, in fact. We try to get the x by itself. So here, class, we'd first need to move the 3 over as a negative to get 21. And then divide away the 7 to get x is less than or equal to 3. Right. Super easy. Unless you divide by a negative. So you get 2x plus 4 negative 5x is greater than 15. Well, here, of course, we'll combine like terms first to get negative 3x. We'll also move the 4 over as a negative 4 to get positive 11. And then we have to divide both sides by negative 3. But remember, when you divide by a negative, class, you guys really don't remember a lot, or you're just really reluctant to speak. This is sad either way. Flip the inequality around. Make it a less than symbol. And here, remember, we wouldn't say 11 over negative 3, but rather pull the negative out front, negative 11 thirds. If we had something like a negative 5 is less than 4x plus 3 is less than or equal to 11. Well, this is called a compound inequality. So again, we want to get x by itself. We need to put a negative 3 everywhere. Remember, it's not so much that you move it over to the other side, but it's more that you put a negative 3 everywhere, remember. And then, of course, we have to divide everything by 4. Again, it's just, instead of only 2 sides, now there's 3 sides. And we end up with what answer here? Good. And remember, on the number line, as we graph this, we would put at negative 2, class, an open circle. But at positive 2, we would put a closed dot, and we would shade everything in between them and go from there. All right. We will finish our review tomorrow. We'll move quickly through tomorrow's review, because a lot of what we're going to talk about in tomorrow's review will be the more recent material that we've discussed. There is no homework this evening, however, other than start getting ready for this exam if you haven't already. You are dismissed.